Hello, my dear students. Before starting, I just want all of you to be inquisitive in nature. Because if you are inquisitive, you can always excel in science. So, let us scratch our mind with some very simple activity. You all have to make a list of 10 things you have consumed since morning. And you have to sort that list according to the table given on the screen. I hope by now you must have sorted your list. And according to the table given on the screen, in the first column, let us match. You must have written in the things made of metal, almirah, spoon, etc. And in the things made of glass, you must have written mirror. And something very interesting, that in the third column, you must have written water, air, milk, sugar, clothes, maybe some tablets, maybe paper, and so on. Now, my question to you is, what these things, what these materials like clothes, milk, sugar, these tablets are made up of? Any guesses? Okay, so we will first do a small experiment and then we'll see what does it have. So let's go. We will simply take a tube and we'll hold it with a test tube holder. Now here one thing I just want you to please listen carefully. I have taken an expired tablet and I will burn that tablet in order to see whether it has some that unique substance or not. But you can try it out at home with paper, maybe with cloth and so on. And make sure you will not burn any type of medicine available at home. I am mentioning it again, I am burning an expired tablet. And in this U-tube, I have filled a colorless liquid known as lime water. After this setup, we will lamp the burner. Students, please do remember that if you are burning, you have to take out that burning process in presence of your parents or your guardians. And then we will start burning of our expired tablet. Students, observe it carefully. You have to focus on the area of the U-tube. Did you see any color change? Yes, that colorless liquid changes to milky white. What does it indicate? Students, you have studied it before in the previous chapters, that whenever you pass carbon dioxide, it turns lime water milky. And presence of carbon dioxide, my dear students, judge presence of carbon in that substance. Students, with this activity we came to know that many compounds have carbon, but you will be surprised to know that the availability of carbon, that is natural abundance of carbon, is very little. Then a question arises, what makes this carbon most versatile element? Yes, now we will find the answer of this question. Carbon is versatile element because of the two main properties. As you know, the atomic number of carbon is 6 and electronic configuration of carbon is 2, 4. And when you talk about its first property, that unique property is known as catenation. What is catenation? Catenation is self-linking property of carbon leading to formation of long chains of carbon or branch chains of carbon or circular, that is closed shape of carbon chains. And this is a task for you. You all have to take help of clay and toothstick and try to make some structures related to straight chain, branch chain and the circular chains of carbon. That means our point is catenation, which is self-linking property. The second property of carbon is tetravalency. You have studied in class 9th, valency means combining capacity of an element. combining capacity. When does an atom combine in order to become stable? Students, now carefully observe this three-dimensional structure for tetravalency. As you can see, in the center you have carbon, and these four lines represents the tetravalency, that is carbon share 4 electrons in order to become stable. Now let us revise these two properties quickly, and I want you people also to do it with me with help of clay and toothstick. I just wanted to tell you that in catenation you can make different structures which are straight chains, these balls as clay and the sticks with the bond. And you can make straight chain structures, you can make cyclic structures, and you can make branch structures out of it. At the same time, you can also make this tetrahedral structure of carbon with the toothpick, showing 4 bonds of carbon. So these two unique properties of carbon shows that carbon is the most versatile element. Okay, now my dear students, a simple question to you. What do you mean by word bond? Yes, rightly guessed. It's a kind of linkage or association. Okay, now again think, what type of bond you have studied in your previous chapter, that is metals and non-metals? Yes, again rightly guessed. It is ionic bond. So, what are ionic compounds? Ionic compounds are neutral chemical compounds made of positively charged ions known as cations and negatively charged ions known as anions, which happens to be by transferring of electron from a metal to a non-metal. And this association is a very strong association. But you have to imagine, my dear students, what will happen with carbon? How carbon will become stable? Question can come in your mind. Will it lose 4 electron? Or will it gain 4 electron? Or what will happen with carbon? My dear students, carbon will neither lose nor it will gain 4 electrons, as it is energetically not a favorable condition. That question arises, what will carbon do? Carbon will become stable by sharing of electrons. So let us understand the meaning of the term sharing. My dear students, whenever sharing of electron takes place, it forms covalent bonds between the elements. And such compounds where covalent bonds are formed, these compounds are known as covalent compounds. Let us explore some more covalent compounds. We'll start with one very basic compound. We'll take up hydrogen molecule. We all know that atomic mass of hydrogen is 1 as well as atomic number of hydrogen is 1. So when we'll do electronic configuration, it is 1. So the outermost electron is represented with 1 dot, as you can see. Now this hydrogen wants to become stable, but in its proximity there is no one to give the electron. How it will become stable? It will become stable by calling one more hydrogen, and this hydrogen also have 1 electron. Now what will they do? They will try to come close and share their electrons. Now you have to make sure that sharing is always shown with some circle. As you can see, this hydrogen is sharing its 1 electron of another hydrogen in its proximity, and again the second hydrogen also wants 1 more electron. And this way the sharing is being done between 2 hydrogen elements. Now if you can see, in this circle you have 2 electrons. You have to make sure, my dear students, these 2 electrons make 1 bond. So in order to represent this molecule, we will simply represent it with a single bond. That's why we say that in hydrogen molecule there is single covalent bond existence. In the same way, we can do another molecule that is oxygen molecule. We all know oxygen is represented with symbol O and the atomic number of oxygen is 8 with electronic configuration 2, 6. Now, we will try to make electrons for oxygen. Oxygen has outermost 6 electrons. So, we will represent it with 6 cross. Now, oxygen also wants to become stable. So, it will call another friend oxygen which also have 6 electrons in its outermost shell. Now, how they will become stable? They will also become stable by sharing of electrons. Now, carefully see how this sharing takes place. Now, this oxygen wants 2 more electrons to be shared. So, this way the sharing will take place for one oxygen. And you can see in a circle all 8 electrons are complete. In the same way, second oxygen also wants 8 electrons to be completed. So, this will also share the 2 electrons of another oxygen in association. Wow! How beautifully it is looking. Students, you can also try it with your own creativity. You can also bring that artist in you and do these things very, very creatively. But now as you can see, there are 2 electrons, 2 pair of electrons. So, now we remove these 2 pair of electrons and represent these electrons with 2 lines, that is 2 bonds. See? It is double covalent bond. So good. Now, we will take up another molecule, that is nitrogen molecule. The symbol of nitrogen is N. Atomic number is 7 with electronic configuration 2, 5. So, this nitrogen will have 5 electrons in its outermost shell. So, we will represent it with 5 crosses. And this nitrogen molecule will become stable with another nitrogen molecule which also has same 5 electrons in the outermost shell. Now, they will also share 3 electrons each. Students, as we have done for oxygen molecule, same way the task for you is you have to do it for nitrogen molecule. We will take up a molecule which consists of carbon for the better understanding for the sharing of electrons by carbon. So, a molecule which we will study is carbon dioxide, which is very famous gas. We all know that carbon has atomic number 6 with electronic configuration 2, 4 and oxygen has atomic number 8 with electronic configuration 2, 6. So, first we will make the symbol of carbon like this and we will put 4 dots for carbon indicating the 4 valence electron. Now, I will put up one oxygen as it is carbon dioxide and then I will put up 6 electrons in the outermost electrons. Now, try to look it carefully. This oxygen wants to become stable by sharing 2 electrons. So, it will try to share up with carbon like this in a circle. But carbon is still not stable. Carbon wants to become stable again. It will request one more oxygen to come in association and this oxygen also have 6 electrons in its outermost shell. Again, this oxygen will become stable by sharing 2 electrons with carbon like this. How beautiful it is looking. But carbon, it is still not stable. We have to show the sharing with the carbon. So, what will carbon do? Carbon will share 4 electrons, 2 with each oxygen. So this way, carbon also has shared its 4 electrons. So see, now the property of tetravalency is completed. Carbon is stable, oxygen is also stable, and the second oxygen is also stable. And in order to represent this in other better manner, we will remove these electrons and we'll represent, remember, we'll represent the 2 electrons with a bond. So, these are the double bonds in between carbon and oxygen. How beautiful it is looking. So, students, please try this type of creativity for some more questions as given on the screen in the practice sheet. You have to try it for nitrogen molecule, carbon tetrachloride, methane, fluorine, chlorine, and so on. So, I hope you like this creativity. Students, do you know diamond and graphite are same? Same? Unbelievable. How they are same? Yes, you have to note this point here. Chemically, diamond and graphite are same. That means if you burn both of them and you try to repeat the same process of passing the gas released from these compounds into lime water, it will turn milky and it will show the presence of carbon dioxide gas. That means chemically, both of these diamond and graphite is made up of carbon. But physically, they are different. That means when you look at its structural carefully, it is different. How they are different? They are different in physical properties, but they are same in chemical properties. This phenomena is known as allotropes, and allotropes of carbon are basically diamond, graphite, and fluorines. First, we'll talk about diamond. As you can see the structure shown here, diamond, each carbon is bonded with 4 different carbons. We'll try to do it with some colored clays. Students, you know, carbon is represented with black, but just to have fun, we are just playing with some clay. We can simply take toothpick and we can make structure of diamond on our own. We have to make sure each carbon is surrounded with 4 different carbons. Now, same way, you will repeat this step in order to look the 3-dimensional structure and you will get this structure of diamond. And what is the observation which we get? The observation is the structure of diamond is very compact. It is the hardest substance known. And if you look at its conductivity, diamond is non-conductor of electricity because there is no free electrons. As you can see, each carbon is bonded with 4 different bonds. Diamond is also used for cutting glasses. It is highly compact, so it has high melting point. You can tabulate these points as per the table given on the screen. Okay, my students, let's talk about another allotrope of carbon known as graphite. As you can see, graphite has a layered structure. It is soft and slippery, and once you take out the melting point, it is not that high as that of diamond. And when you look at the structure of graphite clearly, you can again have that fun activity of making its 3-dimensional structure. As you can see, I have drawn the structure of graphite in the form of a hexagon ring. You can continue making these hexagons with help of clay. You have to do it in a careful manner, where my focus is on this part, that each carbon is bonded with 3 other carbons. Same way, you will continue making the hexagons and you will achieve this type of the layered structure. Make sure in graphite there is presence of 1 free electron, as I have shown you. So, graphite is a good conductor of electricity. Students, let us talk about fluorines, which is also allotrope of carbon. and it appears to be like football, as you can see it on the screen. It is 20 hexagon and 12 pentagon rings interlinked with each other. Now students, let us recall what we did in this episode. We started with test of carbon. Then we have done versatile nature of carbon. We also have done covalent bonding structures and we have done allotropes. So you will be able to draw electron dot structures and show your creativity by making models of those structures using eco-friendly material.